We are returning to our study, our introductory study of pandas, and we're going to now look at Boolean array selection and querying. So again, I'm going to mostly be working on the notebook, but this information is available to you in the video, in the slides themselves. So as it turns out, we're not done with the square bracket operator. We've already seen a few use cases and some of the subtleties that arise, and it's the gift that keeps on giving. It does lots of things, and you do need to become familiar with these things. Pandas is a very powerful tool, but it's a tool with subtleties that you need to master. So as it turns out, you can pass to the square brackets not just explicit value, not just values that are say integers or names of columns, but you can actually pass it lists of true and false values. This happens to be extremely useful, and the reason is that often when you're looking for information in a data frame, you can make queries, and we'll see how to do that later. And there's many operations that basically answer for every element or for every row or every column of your data frame is what you ask true or false. And so these things are actually known, they're typically known as Boolean masks. When you have these arrays, these Boolean arrays, they're often referred to as Boolean masks. And the reason is because you can think of it as a sort of opaque and transparent mask where false would be opaque and true would be transparent that you overlay on the array. So if you have your table and you overlay this this grid of black and transparent squares on it, then it will block anything where you have a false, where you have a black square will be covered and blocked, and then where you have a transparent square, you would see the data in it. That's how I think of it, right? This is why they're called masks, and they arise. There's many operations whose return value is a Boolean array, and so then you use that return value to index into it. And NumPy supports exactly the same kind of ideas of indexing with Boolean arrays for the same reasons. So let's make this particular axis. So let's create this Boolean mask and ask what happens if I index into my elections year. As a reminder, before let's take a look at elections year index again. So we remind ourselves what we have. This is our election year data indexed by year. So what happens if I ask it to return to me these values that have, by providing this mask of trues and falses, this is what I get. Notice that I didn't say head in here. In this particular case, this is all of it, right? The actual data frame is bigger than that, right? It's much longer. But when I said this, what I got was actually only 4 rows. And if you carefully count, you'll find that there's 1, 2, 3, 4 true values in it, right? And for example, I got the last one, 2016 Trump Republican. There it is. We got the first one that's true is this one, which was 1992 Clinton Democratic. So 1992 Clinton Democratic, this row right here. This was the, I think, 7th or 8th row or so, give or take. So this is how a Boolean mask operates. And so this, and as I said, this is a very common, very common operation. This is an example of the kinds of things that generate a Boolean mask, right? If I say, show me where the election year index, the result column is equal to win, right? The result column has either win or loss, win or loss, win or loss, right? That's the data stored in that column is either the string win or the string loss. So I can ask, where is this? Where is this value equal to the string win? And what I get is a series that contains true and falses. So now I can ask, what is the elections year indexed by is win? So this is a way of asking, if we type it out completely, in this case we created the standalone series and gave it a name just so we could look at it, but we can do that on the fly. We can say, give me from the elections year index, give me the index into it with square brackets, and give me when is the result equal to win. This reads reasonably like English, and this reads reasonably like English and gives us exactly that. It gives us all the years where the result was win, which basically tells us these are in our data set, these were the winners of the presidential election. So these were the presidents in that period. But we can also combine criteria. We can select multiple criteria. So this is an example of asking the question. I want to know who won. So where did the election result return win? But they won with less than 50% of the vote. So what are the years where the winner got less than 50% of the vote is basically what this question is. And we do that by computing these conditions and combining them with the AND operator, the bitwise AND, which is the ampersand character. So if I do this, what I get is, for example, if we look at the first 5, that in the first 5 years that are stored in the data, this condition wasn't met. This didn't happen. But we can ask, when did this happen at all? So if we pass this exact same expression as our indexing argument, then we see there are actually 4 years, twice Clinton, then G.W. Bush in 2000 and Trump in 2016, where the winner of the presidential election got less than 50% of the vote, of the total vote. This was a very low number. Some of you may know what happened that year or not. Most of you probably were not born in 1992, but you may still know what happened. There was an interesting political situation that year that led to the vote being basically cut between more people, and you can look it up online. Now, for those of you who happen to know a fair bit about Python, you might ask, why can't I write the word AND here, and instead, like you normally do for matching conditions? The reason is kind of a technical one. It turns out that Python does not allow objects to overwrite the behavior of the AND operator. The arguments to AND have to be single Booleans, and since these objects return things that are not single Booleans, but arrays of Booleans or series of Booleans, then they can't be combined with the AND word. The AND word, you cannot define the behavior in Python objects of how they operate under the AND word. But you can define how they behave under the bitwise AND, which is different from the AND keyword in the language. And so Pandas series and Pandas and NumPy arrays of Booleans do implement sort of proper behavior under AND and OR, but they use the bitwise AND and the bitwise OR. So if we want to ask a question that is, for example, show me when the party was either Republican or Democratic, in this case it's obviously going to give us the whole data set, then this is how we would combine those. Actually, no, I'm sorry. Let me correct myself. This is not true because we do have a few years when we had independent candidates, and so this drops the independence from the data set and gives us only the 2 major parties, Republican or Democratic. Now, it turns out that for these kinds of queries, which are fairly common, there is a convenience operator called the isIn method that actually allows us to ask this kind of question in a single shot. So isIn asks exactly that question. Is the value party, right, is the value contained in that column? And we have to think of it as under the column labeled party, all of the entries. Is that value in the set Republican, Democratic, right? And so it gives us the same thing. It gives us a mask, and so we can, as before, we can use this as a mask to index into it, and we get the same thing as before. We get the major party candidates having dropped the independents. And finally, probably the most sophisticated version of this kind of the behavior that Pandas offers is the query method. And so this is important enough that I want to actually show you some of this documentation. So this is what allows you to do pretty complex queries into Pandas data frame. So what query gets is actually a string. So you don't pass now Python objects, but you pass it a string. And the string represents a query that is going to be evaluated where names in the string refer to columns, column names. So you can think basically of your data frame as a set of variables that are the names of the columns, but each of those variables now represents all the data down that series, and then you're doing query operations across all the rows of the data frame based on the column label. So the normal form of using query is to generate expressions that include column names and that do computations and return masks. You can, if you need to also generate an expression that includes a variable from the outside environment, you prefix it with the @ syntax. As you can imagine, query is a very powerful but fairly complex tool to learn how to use well. You can see that the docstring for query is pretty long here. It does include a few examples. I encourage you to look it up in the documentation. But this is an example of how you use it. If I want to say, show me who won before the year, all the winners before the year 2000, this is how you can do it. You say result equals win, and in this case you can use the word and, because now this is not Python code, right? This is not Python code. It's almost Python code, but it's not exactly Python syntax. This is basically a Pandas query syntax, which is mostly Python-like, but gives you convenience things like this ability to escape and change scope with the @ character, as is explained up here, and to use the standard word and in your queries. If I ask this shows me all the winners before the year 2000. So these are all the elections in our data set before the year 2000. So we're going to pause here for a moment, and we will continue afterwards with other modes of indexing into data frames. But I want to encourage you to take a stop, revisit the section, play with all of the cells, make some changes of your own, try different variations, look up the documentation for these functions, and complete the quick check.